Good day everyone, welcome to another episode of my YouTube lesson. In today's video, we are going to be discussing on how to balance in a chemical equation in chemistry. So let's say suppose we have a sample. Let's say we are asked to balance H2SO4 plus potassium hydroxide. So we write how for our equation. This side is known as the left hand side. So this is our product side. So how are we now going to get our product side? So the first thing we need to know is that we are going to split this into two. But if you notice something here, we have three elements here. We have three elements. So the last two elements that we have here, that's oxygen and hydrogen, SO4 and the oxygen here. These two elements that last here, they can form a radical compound. So what are the radical compound? Radical compound are the compound that normally behave as a single unit. We have the cation form of them and we have the anion form of them. Example, we have the SO4 2 minus, SO3 2 minus, NO3 minus, NO2 minus. What again do we also have? We also have OH minus, we have CO3 2 minus, we have CO2 also 2 minus, and we also have Cr2O7 2 minus, we also have Na3 plus. This is the one of them that is cations, that is positive charge. They are positively charged, and also radical compound can also be negatively charged. So how are you now going to balance this reaction now? You are going to split them into two. Let's say we have hydrogen like this and the SO4. You are going to split this potassium like this, and the OH will also come to the other side like this. So OH, if you notice this radical compound that I put here, they are the radical compounds, they are radicals. So we have OH here. OH normally have the valency of -1. Potassium is belong to group 1 element. They will always have a negative of +1 also. It belongs to group 1. You know potassium is 19. That's 19 atomic number. So if you do it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. See now, they have one valency electron. So that's why potassium is +1. Hydrogen is also +1, and the SO4 is also -2. You can see it here. Anytime you have an SO4 in a compound like this, H2SO4, so you are going to bring the last two elements to one side, so they will be behaving as a single unit. So most of the radical compound they are divided into two. We have the positive one and the negative one, that is the cation and the anion. So now the positive will marry the negative, and we are going to do their combining valency, while the hydrogen also will marry the OH here. So let's now do the combining valency before we copy them to the right hand side of the equation. So the potassium metal is always written first, and the SO4, we said they are going to marry each other, +1. According to the principle I've explained in my previous lesson, you ignore the sign if you want to do the combining valency, and you cross the valency. So we are going to have K2SO4. So we are going to copy K2SO4 here. So for hydrogen and the OH, we are going to have hydrogen plus and the OH minus. So it's not possible for us to now have HOH. No, it is wrong. So we rather write it like this, H2O. So we copy it like this. So plus H2O. So let's now balance the reaction. We have 2 potassium here. So we are going to write 2 potassium, 2 here also, so that we can have 2 potassium here. So how many hydrogen do we have? We have 2 hydrogen here also. How many sulfur do we have here? 1 sulfur here, 1 sulfur here. Let's check the oxygen. Oxygen is 4 here, 5, 6. So 4. So we are going to copy 2 here, so that the oxygen will also 4, 5, 6, so that it also be 6 also oxygen. So I think the equation is balanced like this. So this is how you are going to balance your chemical equation. Let me show you another example. Another example. Let's say second example. Let's say we want to balance equation like CO3 plus HCl. So we want to balance it. This is a binary compound and this is a trinary compound. Anytime you are having a trinary compound, the last two elements here will form a radical compound. They will stand separately, while the potassium here also stands separately like this. Chlorine minus and the hydrogen plus also. So the positive will marry the negative for the other side. So we are going to do the combining valence before we can write them to the right hand side here of the equation. And the positive here will also marry the negative. So let's do the combining valency. So for the calcium and Cl, this one is having negative 1, this one is having positive 2. So you ignore the sign, 2 will come here, 1 will come here. You are going to have calcium Cl2. So we are going to copy calcium Cl2 here. So for the hydrogen and the OH, for the CO3, CO3 2 minus and the hydrogen. So we copy metal first. We're going to copy metal first. So metal is having positive. So it's not possible for us to now have H2CO3. So we cannot write it like in this form of equation. So what you are not going to do is this. So you are having how many oxygen here? You have 3 oxygen here, and carbon and the hydrogen. Oxygen is a non-metal. Carbon can be a metal, and also it can also be a non-metal. So we are going to do it like this. Hydrogen will combine with one of the oxygen. So we are left with how many oxygen now? 2 oxygen. So the 2 oxygen and the carbon will now remain like this. What is the valency of oxygen? -2, +1. So this one and this one will come together. We are going to have H2O. So we now left with CO2. So we are going to copy it here. H2O plus CO2. Now we now balance our reaction. So if you look at it, we only have 2 chlorine here. So we are going to copy 2 chlorine here and 2 hydrogen here. So the equation is balanced. So this one is solid. This one is aqueous. This one is also solid. This one is liquid, and then this one is also gas. So it comes to the end of today's lesson. So if you are new to my YouTube channel, please kindly subscribe to my YouTube channel in order for you to know when I post the next video. Thank you.